What is high availability? How do you make your applications highly available? And what is all the talk about those nines? Let's find out. High availability is a huge topic. So we're not going to be able to cover everything in this video, so we'll make a series out of this. And today we will only look at the definition of high availability. Then we'll talk about the nines, triple nines, quadruple nines. And then we will go hands-on and we'll see a sample architecture using AWS cloud technologies. And you can see how easy it is to build a highly available infrastructure and a highly available, maybe a web service or an application with cloud technology in multiple availability zones and in multiple regions. So what is high availability, or HA as it's oftentimes called? Essentially, when we're talking about an application, a web service, a website, whatever it is, we want to make it available, right? Available to your customers, to your users. And when it's functioning properly, the way you intend for your application to function, then we talk about uptime. So it's available, it's online, people can reach it. When something is not available, and this can be planned maintenance or some issues during a deployment or whatever it may be, then we're talking about downtime. And in high availability, so HA, we want to maximize our uptime and we want to minimize the downtime. And this brings us immediately to all of those nines, triple nines, quadruple nines. This is just a number, a percentage number that describes the percentage of time in a full year that your application, your web service is available. So with 90% availability, we're talking about 90% of a full year, so 365 days in a year. And with 90%, it means your application is down, not available, for 10% of this whole year, which results in 36 and a half days. So this is huge, right? No modern application would be okay and customers would use it if it was offline for a full month, more than a month in a calendar year. So in modern applications, we strive, for example, for 99.9% of availability in a full year, which results in about 9 hours of downtime in a full year. And this is what we call triple nine. And for example, in quadruple nine, which is 99.99, we would only be allowed to have planned or unplanned downtime for about 52 minutes for a full year. So you can already see that both 9 hours and 52 minutes is not a lot of downtime. So in both of those cases, we cannot, take our applications offline for, let's say weekly planned maintenance as we would do in the past oftentimes. It's just not enough time. So we have to find ways to not only make or minimize our unplanned maintenance, bugs, broken deployments, network issues. We also have to plan our planned maintenance. How do we make, let's say database updates and these kind of things so that our availability stays high? We cannot afford to take out or to take offline our database if it's a single master database for a few hours every week or every month. We have to consider many aspects for an application to be highly available. So there is an architectural aspect. How do we design our systems and our infrastructure? How do we connect it in a way that it ensures high availability? Then we need to take care of the testing and QA. So how do we make sure that the architectural decisions and mechanisms that we put in place are being tested on an ongoing basis, every day or every week or whatever it may be? Third, we have to think about deployment strategies and change management strategies, because things change, database schemas change, code changes all the time, capacity changes. So how do you make it that even if all of the teams in an application or contributing to an application, maybe in a microservice environment, can deploy without affecting each other in their uptime? And lastly, we have to cover organizational aspects. So how do you make people aware if things go wrong? We talk about monitoring and alarming, but also having people on, let's say, pager duty, developers or operations folks, that if something goes wrong and maybe it's in the middle of the night, that they are available. Now, before we jump into a sample architecture, let's talk about some of the prerequisites of making an architecture highly available. In the past, if you think about an on-premise environment where you would run your own hardware, or maybe you would rent space and hardware somewhere, and you would deploy your applications, your code to those on-premise environments, if you wanted to make your infrastructure highly available, you would need to have multiple of those physical locations. Because what if one of those buildings, one of those data centers just burns down? It happens. What if there are power outages or somebody trips over a cable? All of that stuff can happen. So we need to not only distribute our application and our code on multiple machines, but across multiple physical locations. And you can already see where I'm going with this. In today's world, this is possible even for small companies and even freelance developers, because they can leverage cloud technologies. For example, AWS offers 25 geographical regions for you to use. And really with a few clicks, you can take your applications and you can make it so that they run and deploy in, let's say, America, in Europe, and in Asia. And there is absolutely no effort for you to be at those physical locations, have people there, employ people there, no maintenance for you to do. So it makes it way easier to design and build a highly available system, because you can leverage those regions, those data centers in very distributed and diverse geographical regions. So cloud technology is really an enabler here. And for example, with AWS, we have right now, as we're speaking, 5 new regions coming up, which is Switzerland, Spain, we have Jakarta, we have Hyderabad, and we have Melbourne. So that brings us to 30 regions. And if you keep thinking along those lines, you will see that this opens up more interesting possibilities and options for us. With multiple regions, you don't have to leave your, let's say, failover region just there as a standby. It can actually take traffic as well, right? So you could have, let's say, one region in Europe and one in Asia, and the region, so your application in that Asian region would be taking traffic from this area, which is great for your customers because they're closer to that region, and so latency would decrease. And on top of that, you can think of interesting deployment strategies. So instead of deploying, all of your new code to a single machine, so essentially taking out that single machine and replacing the code on that machine with the new code, you can now do, gradual deployments. Maybe you switch only the code on one of the EC2 instances in one availability zone, and then gradually you deploy to the other machines after a certain amount of time. So you want to make sure that your code is running in a productive environment. It's running fine there, it doesn't trigger any alarms, and then you would start deploying into those other availability zones or even into those other regions. So what's the idea here? We want to take our application, which is maybe running only on a single machine today, and we want to deploy it to multiple so-called availability zones. So in other words, in multiple, for example, data centers. And on top, we want to even deploy it into multiple regions, so that not only is your application and your data stored in multiple data centers, it's also stored on different continents, for example. And many big companies and also small companies do that today because it's so easy, and you can do it as well. And we will take a look at a sample architecture right now.
Here we go. This is a sample architecture of what we just talked about.
In this case, and let me walk you through from top to bottom, we have our user who uses the browser, some sort of internet browser. And let's say we own this domain, example.com, where we have hosted our different applications, websites. And in this case here, we're leveraging a technology from AWS, which is called Route 53. This could be any DNS management service. And the request, let's say there's a GET request incoming up here to something example.com, is then routed to a region. And here, as I mentioned before, we're going to use as an example the EU West 1 region. So the request, without the user knowing this, of course, lands in this EU West 1 region. And here things get a bit more interesting. So first of all, we need to have a load balancer in place. This load balancer will help us distribute traffic between various availability zones and various instances. So before, you might have had a single one of those web app instances, which the IP address of that one you would register with your DNS. So here we have something in between, which is the load balancer. So the load balancer is registered with this DNS service up here. So in this case, Route 53 knows exactly where to find the load balancer with the domain webapp.eu.example.com, right? And this, of course, this DNS service would not only manage this single load balancer, but maybe many more applications and other stuff. Anyways, the load balancer is a critical component because, first of all, if it's just a single instance, it would also be a single point of failure. In the case of the elastic load balancing services from AWS, this is not the case. This is per se already replicated into multiple availability zones. So you don't have to worry about replicating and making your load balancers highly available, right? So the load balancer has the chance and the option to route the incoming traffic, so this GET request, to different web apps, different instances of this web app. And it also needs to monitor, so I have this icon down here, it needs to monitor the health of all of those instances, because the load balancer needs to know which of those instances is healthy and can take traffic. So at any point in time, either one, two, or all three of those web app instances in those three availability zones could become unhealthy because of whatever reason, hard drive full, power outage. And at that point, the load balancer needs to understand that and needs to stop routing traffic to the web app because the request wouldn't be fulfilled successfully, right? The user would be waiting, nothing would happen, the request would probably time out. So the load balancer usually uses so-called health checks, where it can ping the instance and it can check for a certain response or a certain response time maybe. You can define all kinds of criteria for your health checks. But this is in itself already a so-called multi-AZ, so multi-availability zone architecture, because each of those three web app instances can go down. You could even survive a failure of two availability zones. So the availability zone, let's say the data center where this single web app instance is placed, because you would have a third one here. The chances that two of those availability zones become unavailable at the same time is very, very low. So you're already doing quite well with this setup. And this is an extremely low effort setup for you to create, because load balancers in AWS, for example, are perfectly equipped to do exactly this. So health checking out of the box, so to say, it can deal with multiple availability zones. It can also deal with the number of instances in these availability zones changing. So you could, let's say you have a busy period of the year, You're selling products for Christmas on your website, for example. You could add another instance into this availability zone, another instance here, another instance here. Those instances, they would be registered with the load balancer immediately, and the load balancer would understand, okay, I have more capacity in some of the availability zones now, and I can route more traffic there. And so it does exactly what it's supposed to do. It balances traffic. Now, we haven't talked about the more interesting maybe, or even more sophisticated version of this, where you would want to have a multi-region architecture. And multi-region would mean we take all of this stuff, and let me just copy this. And I want to have another clone of this. So you can already see a few things which become very interesting here. First of all, it needs to be easy for me to just deploy into another region. As I mentioned before, this has to be, this can't be something where you have to actually set up another physical location. It would be way too much effort, right? So you want to use some cloud technologies where you can do this very easily. And you also want to use things like infrastructure as code, where you can actually configure all of this infrastructure here as code, and then just deploy this code so that it creates a clone of this into another region. That's a topic for a different day. Now, here, this is a different load balancer. Maybe we want to call this one Web App US. So the host name of the load balancer will now be Web App US, and here it's going to be Web App EU. And for this to work, we could do a few different things, right? We could leave this as it is, and it could work as a very, very simple failover region. So we'll put failover region here. And then I'll make that a bit bigger. And then let's say we would serve all of the traffic in this region. And then only if this region would go down, we would notice that maybe the whole region has an issue or networking has an issue. Then we would manually change the DNS record with Route 53, for example. And we would take this arrow, so to say, and we would now point all of the traffic to the load balancer running in our failover region. And this would now serve all of our traffic while EU West 1 is maybe down or having some issues. What's the downside here? Definitely, it's not for free to run all of this infrastructure just in case of a region disaster, right? And usually the chance that a whole region is affected is fairly low. So it's maybe not the most efficient use of our money to do it this way. What we could do instead is use US East 1 just as a second region that serves customer traffic from, let's say, the US or North America or all of America. So in that case, we would need to maintain both of those DNS records, and we need to rely on Route 53 here on our DNS service to do the routing based on certain criteria, right? Like in some cases, and for some customers, we want the DNS service to route to the EU environment, and in other cases, for other customers, we want the DNS service to route to US East 1. So a few options there. Fairly simple options would be you can use features of Route 53 like proximity routing or latency routing. So this service actually will determine where the user that is making the request is physically situated. And based on the distance from the user to this region here, or this region, Route 53 will make the decision for you. So it would route users which are close to the US region into this side of the picture. and it would route the other users to the EU West 1 region. You could also use something like latency-based routing, where the service, the DNS service, will by itself understand what is the latency between that user and this region, and the same user and that region, and it will pick the region where latency is lower. So the requests would be optimized by latency, so that your users would be routed to the lowest latency region. And this is this is not a simple thing to do in the sense of all of the logic that sits in here, but services like Route 53 make it really easy for you to leverage all of this functionality. You don't have to implement that logic yourself. You can just define which type of routing criteria you want to use. On top of that, you can use things like the health checks of Route 53, which could, for example, have health checks on both of those load balancers. And then in case that this load balancer here would go down for whatever reason, the whole region would be down maybe, Route 53 would realize that and would stop routing traffic. So this would be gone, and it would route traffic to US East 1. So we get the benefit of both, right? We're splitting traffic, we're improving the customer experience, and we still have this concept of a failover region, where if this whole region has issues, we would route all traffic to US East 1. And this is great, right? That's exactly what we wanted. There's one thing to consider here. Load balancers, they don't rely on the DNS system. They rely on their own mechanisms to health check hosts, and you can configure the frequency and the timeout values for those health checks. So if one of those instances goes down, the load balancer can, in a few seconds usually, take out this route, so to say, and not route traffic to this web app anymore. With DNS, things are usually a bit different, because the way DNS works is like these hierarchical systems with various timeouts, and you don't have control over all of these timeouts, because in reality there could be many more DNS servers in between your DNS service and your users. And so the routing, when the DNS routing, if you want to take out a route or change a route, so to say, can take a few minutes to propagate until you would actually route traffic from a, let's say, broken region to a functioning region. So consider and keep that in mind. If you can avoid it, try to route as much as possible in the load balancer here, and keep DNS-based routing to a minimum, because load balance routing will just be usually a lot faster. So today we discussed a multi-AZ, multi-region sample architecture. And it's really easy for yourself to sign up for an AWS account and try all of those things yourself. You can really build applications with a few clicks and deploy them into multiple availability zones and even multiple regions. I'm very excited for the Switzerland AWS region coming up in 2022. So keep an eye out for that one and for the 4 other regions that AWS is launching soon. And if you have any comments, if you have any questions about these concepts and these topics, let me know in the comments. My name is Ramon Lopez, and this is Success in Tech.